Prove that if the sequence an converges to A, but is never 0, and each an is never 0, then the sequence 1 over an is bounded. Proof. We're going to assume the sequence an converges to A, and is never 0, and each an is never 0, then, by definition of convergence, for every positive epsilon, we're actually going to choose epsilon equaling to the absolute value of A over 2, and we're going to choose an n in the naturals such that for all little n greater than or equal to capital N, we have n minus A is less than, we chose our epsilon to be absolute value of A over 2, and by the reverse triangle inequality, we get the absolute value of A of n minus the absolute value of A is less than the absolute value of A of n minus A, which we know is less than the absolute value of A over 2. And I'm going to use this inequality, where we have this outer absolute value on that's less than, this is less than or equal to, that's less than absolute value of A over 2, and I'm going to use this to say that from negative absolute value A over 2 is less than absolute value an minus absolute value A is less than absolute value A over 2. And then I'm going to add absolute value A to every side. So over here, because this is negative 1/2, we just get absolute value A over 2 less than absolute value n less than 3 absolute value over 2, because we added 1 to 1/2, so we get 3/2. And then from here, we know that A is never 0 from our assumption, and we know that A of n is also never 0 from our assumption. So I can take the reciprocals of everything, which would flip my inequality, but I would get 2 over absolute value A greater than now 1 over absolute value an less than 2 over 3 absolute value A. And now we can see that absolute value 1 over absolute value an is clearly bounded, which is our conclusion. Thus, the sequence 1 over an is bounded. There we go.